Welcome to my channel, and this is Grace Tutor. And what I do here, I solve technical drawing problems and also provide very important information that will be useful for you to have a better performance in your technical drawing examinations or engineering drawing examination. And as I said, I usually provide important information solving technical drawing problems. And here now, I'm here to share a very important information with you about the construction of triangles. I know that for every technical drawing student to have a better performance in this subject, you need to know some things about it. You need to pay attention to every detail that has to do with that particular construction. And here is what we are to talk about the information about the construction of triangles. And here I'll be sharing with you what you need to know about the construction of triangles. And the first one that I'm talking about here is that how to construct a triangle where we are given the base angles and also the altitude. We are given the base angles and the altitude. What you are given for the construction of that triangle is very, very important, and you have to make use of them for you to construct the triangles. So now that we are given the base angles and the altitude, so this is how the construction will look like. And looking at it as we have here, so this line AB is just a horizontal line that we need to construct. And also the distance between line AB and line CD is equal to the altitude of the triangle that we are given. So distance between line AB and line CD is equal to the altitude. And then the angles that we have at this point, so the angle at this point and also the angle at this point, they are equal to the base angle. So what we need to do for this construction is to draw line AB, we draw line CD, and as I said, the distance between line AB and line CD is equal to the altitude of the triangle that we are given. So then we locate this point E here with the use of our protractor. We need to get this angle and we need to get this angle. Then getting this angle, so from this point now, we draw a line to meet line AB to get point G, and we draw a line from this point E to meet line AB for us to get point F. So that gives us this triangle GEF or EFG. Then this angle and this angle, they are equal in size, because as we know in mathematics that alternate angles are equal. So the same applies here, that this angle and this angle, they are equal in size, and this angle and this angle, they are equal in size. So let's pay attention to that. So when you are given the base angles and the altitude, this is how the construction should look like. And as I said, distance between line AB and line CD is equal to the altitude of the triangle. And do not forget that this angle here and this angle here, they are equal in size, they're alternate angles, and this angle and this angle, they are equal in size, they're alternate angles. So that is number one. The next one that we have here is that we want to construct an isosceles triangle when we are given the perimeter and the altitude. Construction of isosceles triangle given the perimeter and the altitude. So when you are given this information, this is how the triangle will look like. And what are we to do in the construction when you are given the perimeter and the altitude? So you have to divide the perimeter into two. That is first thing I need to do. You divide the perimeter into two and you draw line AB. So line AB is equal to the half of the perimeter, which means if the perimeter is 100 millimeters, you have to divide it by two and make use of 50 millimeters. So this line AB is equal to the half of the perimeter. Then you have to erect a perpendicular line at B. As you can see here, you draw a line at a right angle to line AB at B here. Then the altitude of the triangle now, so you make use of it. So this line BC is equal to the altitude of the triangle. Then you connect AC together and bisect AC. You connect AC together, then you bisect AC. By the time you bisect AC, this is the bisector. So you draw this bisector, and the bisector touch line AB at this point D here. So all you need to do to get point E is to take distance BD, and then you mark it at this point E here. Then you connect CD and CE together to get the isosceles triangle. So let me recap what I've said for you to get it again. So I said when we are given the perimeter and the altitude of the triangle, so what we need to do is to divide the perimeter by 2 and we draw half of it. So this line AB is half of the perimeter. Then you erect a perpendicular at B. You erect a perpendicular at B. Then you make BC to be equal to the altitude given. So, and then you connect AC together. Connect AC together. You draw line from A to C or from C to A. Just draw the line to connect AC together. Then you bisect line AC. So when you bisect line AC, as we can see here, so the bisector, it touches line AB at this point D here. So the next thing that you need to do is to take the stance BD, then you make an arc on the extension of the line. That will give you point E. So connecting CD and CE together gives us the isosceles triangle that we are given its perimeter and its altitude. So as simple as I've said it now. So then let's look at the next one that we are to do. As I said, that what we are given for the construction is very, very important. It's very, very important. So in this case now, we are to construct a triangle when we are given the base, the altitude, and the vertical angle. We are constructing a triangle when we are given the base, the altitude, and the vertical angle. So those are the things that we are given for this construction. And this is how the construction will look like. Now, so let's start. The first thing to do is to draw the base AB. So the base AB, line AB is equal to the base. So if the base is 50 millimeters, so all you need to do is to draw line AB as 50 millimeters. Then the next thing to do is that you have to draw line AC that will be at an angle to line AB. So the angle between line AB and line AC is equal to the vertical angle. Please pay attention to all that I'm saying here, because in exam they can test you that the angle between line AB and line AC is equal to what, and you have the options to choose from. So as I said, the angle between line AB and line AC is equal to the vertical angle. So if you are given the vertical angle at 60 degrees, so you need to make the angle between line AB and line AC at 60 degrees. So I hope that is taken. So as I said, so for this construction, we have to draw line AB equal to the base given, and then angle between line AB and line AC is equal to the vertical angle. Okay. Now, the next thing that I need you to pay attention to. So after you have drawn line AB and you have drawn line AC at an angle to line AB, in which the angle is equal to the vertical angle. So you have to draw line AD. And this line AD is at a right angle to line AC. Let me say it again. Line AD is at a right angle to line AC. So which means line AD is at angle 90 degrees to line AC. Okay, so that is very, very important. You may be asked that the angle between line AD and line AC is equal to, so don't forget that it's equal to 90 degrees. So line AD is at a right angle to line AC. Now, having done that, having drawn line AD, we are going to bisect distance AB. We are bisecting the base line AB. So bisecting it, we have this line. Now, this bisector, it intersects line AD at this point O here. This bisector, it intersects line AD at this point O. So then we have to draw a circle. This is not a semicircle. What you see here is not a semicircle. So you may be asked, it is not a semicircle, it's a circle. It's just that we do not complete it. So putting the pinpoint of our compass at this point O here, and we extend it to point A or we extend it to B, because distance OA or distance OB is equal to radius of this circle. distance OA or distance OB is the radius of this circle. So we put the pinpoint of our compass at O, extend to A, or we extend to B, then we draw the circle. So as you can see here, it is not the circle, as I said, it's not the complete circle. There's a circle, it's not the complete circle, just drew an arc. Okay, so now having drawn this circle, then we have to draw line EF parallel to line AB, and distance between line AB and line EF is equal to the altitude of the triangle, is equal to the altitude of the triangle. So having drawn this line EF with the altitude given, the line EF, it meets this, it touches this circle at this point G. So all that we need to do now is that we connect BG and AG together to get the triangle. So that is all that we need to know about this construction. As I said, that for this construction, we are given the base, we are given the altitude, and we are given the vertical angle. Okay, so let me say it again, as I said, that the angle between line AB and line AC is equal to the given vertical angle. So let's pay attention to that. So the next thing that you are going to do here, let's look at the next one. So in this case, we are given the perimeter and the ratio of sides. We are given the perimeter and the ratio of sides of the triangle. So for this construction, this line AB is equal to the perimeter. Line AB is equal to the perimeter, and then we have to divide this line. So we have to divide this line AB into a number of equal parts, which is equal to the sum of the ratio given. Let me say that, for example, let's count what we have here. I think this is 1, 2, 3. So that is 3, and this is 1, 2, 3 again. That's another 3. Then we have 1, 2, 3, 4, 5, 6. That means what we are given for the ratio for this construction is that we are given 3. Let me get it right. This is 1, 2, 3, 4, 5, 6. So that's 6. 1, 2, 3. That's 3. 1, 2, 3, 4. Okay. So what we are given for this, for the ratio for this construction is that we are given 4:3:6. We are given 4:3:6. As I said again, 4:3:6 is what we are given as the ratio of sides in this construction. So we are given the perimeter. I said AB is the perimeter of the triangle, and AB is the perimeter of the triangle. Then we are going to sum the ratio together. That means we have 4 plus 3, that is 7, and 7 plus 6, that gives us 13. So if you count the number of divisions that we have on this line, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's 13. So that is what we have added together. So now, we divide this line, as I said, into 13 equal parts. And that's why we have this line, we have this line, we have this line. These lines are parallel to each other. Then having done that, so this line CD is equal to the base of the triangle. So then we put the midpoint of our compass at point D, and we extend to point B, and we draw this arc. And then we put the midpoint of our compass at C, we extend to A, we draw this arc. So wherever they intersect, that gives us point E. Then we connect CE together and DE together to obtain the triangle whose perimeter and ratio of sides are given. Now, let's pay attention to this. The radius of this arc, is equal to DE, and the radius of this arc is equal to CE. Let me say it again. The radius of this particular arc is equal to distance DE, and radius of this arc here is equal to distance CA. So this is how the construction will look like when we are given the perimeter and ratio of sides. So this is how the triangle will look like. Now let's look at the last one here. So for the last one that we have here,